We're going to talk about, guess what? Atomic design and React. So we're going to talk about design systems, React, Cosmos, which is our design systems. But I'll focus a little bit on the butt of the atomic design and some conclusions. I'll try, so you will see some repetitions of the previous talks, but also some differences. So maybe we can discuss about the differences, the different point of view versus atomic design. So, hello, I'm Italian, by the way. So do you see the do you see the pattern here? Boom. Okay, and I work for Badoo. Badoo is I work as UI engineer in the mobile web team. So this means a browser in a mobile device. Every possible browser, every possible device, every possible resolution. And Badoo has now nearly 400 million users worldwide. And we cover all the possible platforms, so iOS, Android, mobile web, desktop web, and up to a few months ago also Windows Phone. Again, I work in the mobile web team. We are not hiring, surprise. Some concept about design system, probably you already heard about it, okay? This is the classic components, clear, cool. Okay, how do you use components? Classic, use the components, Lego, classic, you build a library. With the library, this is the point, you can build different pages or different apps. So that's the main idea, okay? Cool. But what is a design system? Well, a design system is like a cake. Okay, you have your UI components, but they can stay in a Git repo. Then, what do? You use them, okay? But then you need to add documentation. As soon as you add documentation, you have a style guide. So you explain how to use them. But even if you build them, you are missing out people and process. So how you have to involve people and you have to design a process around the fact that how you use components, how do you update components, how do you release new component, how people interact inside the company, and so on. And this is a design system. Cool? Actually, no, it's even more complex because this involves documentation, content strategy, brand, design principles, and so on. So it's a very complex system. And this is the classic golden definition of a design system by Nathan Curtis. What I want to stress is that a design system is a product, so this means also with a backlog, but it's not a product per se. It needs to serve something else, an ecosystem, which is the list of products, the company, and so on. We don't build design systems just for the sake of building design systems. Every company nowadays has a design system, more or less, as you have seen, and the benefits are clear. They already spoke about it. Consistency, better alignment of process between design and development, better efficiency, you have a living documentation. You start to have something more important, which is communication, collaboration within the company, but sometimes can also use for marketing, branding, and hiring. Oh, this is my cool design system, come and work for me. And that's how you feel when you have a design system. Yep. If you want to know more, there is this presentation I made, I don't remember, like 2 years ago. There is everything about design systems and so on. Okay. Where comes React in this part? Well, everything was possible, everything started a few years ago when the idea of this atomic design by Brett Frost was combined with the idea of web components. This is the classic web components, not React, not anything. But there was this idea of components, and this will come later, this idea of composition. You compose elements to obtain something else, okay? And this started to be a common ground, as we saw, between designer and developer. So designer and developer, they start to use the same word, card, for the same component. And so all the misunderstanding that there was before was mitigated by this use of the same semantic names for the same object. And React made everything more simpler, possibly, more streamlined, and so on. And now it's predominant. Like, this is one of the repository where you can find like the list of the biggest, if you want, design system across the world, and so on. You can clearly see like the big part are built in React or no frameworks at all, which means essentially just CSS. Some in vanilla, some multiple stacks, and so on. If you want to know more about this interesting relation between design and coding and development, there's this amazing article by Mark Daglish that explains a lot also about the new tools that we are starting to think in terms of or generating the code from the, let's say, design tools, which probably will not happen, or the other way around. So use the code to generate the mocks inside the design tools. So the designer, they design using code, essentially. Cosmos is our design system. I can show you a little bit. It's not public, so we have the classic list of components. You can search for components. Like we have the core components. If you see, we support multiple teams, multiple brands, we call it, but also multiple platforms above. This is like the typography. We have different typographic styles, classic iconography. This we will see maybe in a moment, this component called avatar. We have a brick, which is used a lot in our application. The classic button with all the possible variant of colors, states. If you see here, we have different states for the button, so there is a visual representation. But if you see, the size of the button changes across different platforms. And here are the inputs, all the classic shebang of a design system. No, it's not even public. And with the toggle, you can see the code below, but also you can see all the documentation about a component, the API, about how to use it. And there is another one, which is called Playground. We will see in a second. So again, the API of the buttons. But in the Playground, you can play, let's say, change the properties live and see the button change in front of you directly. And you can even input the code here and you will see the changes. And this is a way also to allow other people to understand the API of the component, if you're a developer or if you're a designer, see the state of this component. Let's talk about a little bit about the code base. As I told you, it's built in React. We use Sass and BEM notation. We don't use any JS and CSS for the moment because there's no big need. It's not essentially once you have broken down to small components, it's the cost of changing from one technology to another is so small that once we will find the need to switch to, I don't know, style components or CSS modules, we will do probably in one day of work, so we don't find the need of it. This is the folder structure of our project. Essentially, we have three different, let's say, big, it's one single report, by the way, and we don't version the single components. We have only versioning for the entire repo. And we have design tokens. Imagine like JSON that store the information about one component, about designs information, like Badoo, all the colors, but then you have like the button. You can have different button size for different platforms and so on. So imagine like the description of the core principle, you call them particles. Yeah. Huh? Okay, the particles of your design system. Then you have the components built in React. Again, flat structure, as he suggested, right? You suggested they instead edited, they don't use flat structure. Flat structure, the CSS is in the same folder. If their test is in the same folder, we'll talk about test in a second. And then we have the style guide, which is essentially the website that you just saw. It's a React web app in which you have all the components described in, let's say, pages if you want, and plus components for the style guide. I'll show you a little bit of code in a second, things to notice if you want. We tend to use pure components like other people, so essentially there is no state, there is nothing, because it's a UI component. We split component a lot in subcomponents, not too much, so be careful, because otherwise you end up with powder, not anymore atoms. We use prop types as many other. We use BEM notation, as I told you. The class names are namespaced because we are using class names as a way to declare the style. You may have conflicts somewhere else. If you call something .button, probably you will have a conflict, so it's better to have a class name prefix for your class names, which is the class name for the namespace for the component library. And we use a lot of design tokens for the essentially these design tokens that you saw before in JSON are converted in essentially XML for Android, plist I think, or JSON, I don't remember, for iOS, Sass or CSS or whatever you want. So from one single source of truth for the designs tokens, you generate a different file and they're imported in the system. No? Let's look at example, come on. At example for a simple component. Very simple, you have two different states if you are verified or fully verified, and the size of this component. And the code is very simple. Prop types, we use class names, we require, can you see the space between, we tend to group okay, these are the imports related to React if you want, and these are the imports for this component. We declare prop types and default props before the component, so it becomes documentation. They're all annotated with comments, which means then we can generate the documentation that you saw when you were switching tab. You saw all the documentation, it's generated by this comment inside the code. And then we, as you see there, I don't have the pointer, sorry, we declare simply, maybe I can zoom in a little bit here. You can, come on, yes. It's very simple, we use the icon and so on, and nothing special. I can show you verification status CSS. This instead is the CSS SAS file. Can you see token, color, product verification, which actually is an alias to token, color, vanilla, whatever it is, okay? Here, 10 pixel is not a design token, is not used anywhere else. Makes sense to use it here as 10 pixel. So don't overuse the design tokens. There are other design systems that you have thousands of design tokens, but they're intended to be like edited by the developers. In our case, as someone else before us said, we want to have the components closed, so not someone else editing the state or the look and feel of the components. The components are pretty close because they have been designed by designers. Let's look at something more complex. Essentially, it's called avatar, a brick actually, which can contain an avatar, which is a photo or an icon or a placeholder for text, and also can have a badge or some text on the corner, central or on the left. Code, I'll show you the code in a second. Yep, no, yeah, yes, okay. Look here, okay, props, nothing important, but look here, can you see how I've broken down the avatar, or more similar, sorry, I was showing you the badge, the brick, yep, this one. Again, props, a lot of props, but actually these props are nothing more than props which are passed down to subcomponents. So if you look here in the brick, actually I have very small, zoom out a little bit, very small subcomponents. So I have a big component, which is a black box from outside, but actually I delegate the responsibility of small parts inside smaller components. And this allows us to compose easily things, and especially refactor things without impacting something above, because this is a black box. You don't know what's inside the brick. I can completely redesign completely the API, no, the API no, but the content of brick, and you will never know it. Okay, some numbers just to give you a rough idea, some 10,000 lines of code of JavaScript and 5,000 lines of CSS, SAS. 36 components and 98 subcomponents, 180 visual regression tests. You will see in a second what it is. And more or less, we have like a list of possible components that we could build, and we cover more or less 70% of our UI. Visual regression test is a different way to test the UI of components. In theory, we can use just snapshot testing. I prefer to use this one because essentially, even if you refactor, imagine that you refactor the code of a component. The tests are failing. Is good, is bad, I don't know. Here, you can completely refactor one component, but if the look and feel, which is what I care at the end, is the same, the test doesn't fail. Here is essentially there is a tool that takes a screenshot of one component or one part of the page, save it on your machine, and later when you rerun the test, we'll compare the screenshot with the current screenshot. If there are differences, this test fails, and it's called visual regression testing. At this URL, there's a nice presentation about visual regression testing. If you want to read the full story of this design system, there are 3, not 1, blog posts on Medium. These are address. By the way, I share the slides on SpeakerDeck maybe tomorrow and tweet about them, so all the links are clickable and you can follow the resources there. Now let's talk about the but, which is the interesting part, I think. Okay, this is one thing that more or less we discussed before, which is the direction of componentization. Atomic design is cool. Well, I use an atom, I build a molecule, go up, up, up. First of all, not many people understand what template is, which was his question, which was one of the problems. That, yeah, I understand the organism. What is the template? And this is the reason is because atomic design was thought in terms of websites, not web applications. So that's why we think in terms of pages, because this was the idea. No? You have a template, blog post, the template index page, the template list of blog posts, the template of contact, Web applications are not this anymore. They're complex, they're combined. Each page, if you want, you switch state, you don't reload the page. So maybe you click and something else appears in the same page. Is a different page? No. So that's the reason why this is complex, to move from organized to page. The second thing is, and this is how design system at General Electric called Predix was built. Designers don't work in this way. Yes, they can, but up to a certain level. Then you need a holistic view to your design, to your application. And that's why they completely switched the way in which they think in terms of design. As they say, they start with application, then they go down feature, templates, components, basic, and principles. Okay, they completely change the direction of componentization, which is something I strongly suggest you to do. Understand this one, but then when you design or when you discuss about, okay, we have to implement this feature, discuss it in this way, then go back and understand how to compose, and we'll get back to this, why actually this is very important, okay? The second but is the atomic problem. Everything is a component. Don't start to discuss about, oh, this is an atom, this is a molecule, and it's not me. Jinan, probably one of the most famous contributor of the design systems ecosystem, Nathan Curtis, the god of the design system, Trent Walton, Adam Morse, many others. So everything is a component. Stop every discussion. It's a flat structure. Do you remember? In the folder, here. In the folder structure and in the component structure. But if you see there are small icons on the side, which means, then your architect is going to say, nah, they're just fake. They're icons attached to one list in a navigation bar. The day that we change mind and say, this is not anymore a molecule, this is an organism, okay, change class to the list item and you're done. Okay, and also, can you see this layout? Okay. When we started to build components, we realized there are two different kinds of components. Something which is called layout, something which is similar to layout. Is not per se, it's not a component, it's a component that you use to organize something else. And something which is actually some content with some styling, some colors, and stuff. And then when you combine them two, you remember the idea of composition, to create a real component. No, sorry. The component that the designer was thinking to. The designer never thinks in this term. It's really hard. I struggle still today to have the designer think in these terms. They start, but they struggle. And they don't understand that the spacing, they say, I have my nice spacing, 8 pixels, 12 pixels. Yes, but between what? You have to express something like this in your sketch file. You have a template, and then in your template, you add your content, no? Do you remember this idea of composition? We discussed it before. This is composition in React, but also as designer. I compose two components and I obtain something that this is what I want as a designer, and as a user, I interact with this one. I don't interact with this one or this one. So that's the main idea of composition, and comes back from the web components, no? So how to look at your components? They already told you, break down components, not too much. You end up with dust. What does it mean, break down a component? It means as CSS developer or as like form CSS developer, we have this approach. I have a button. And then we say, but when I use this button in this context, instead of red is blue. Okay, you have two ways. Classically, one is go to the parent, say dot sidebar, okay? And so when you express the class, you say dot sidebar button, size 22 pixels. So you go up, okay? And the other way, classic is, I have this button and the designer is asking me something which is similar. Well, you know what? I create button dash dash something. It's a variant of a button. So your natural way of working is going up. So imagine that in this context or sideways. It's like, I have this component, now this component does also this, and then this, and there's this. Don't do it, break it down. Understand, if you have component A and component B, what is the common part? And then you break it down in something which is common, which is C, and A and B are consuming C, right? C, isolated, even black box if you want. Do you remember I did, no? So you have small components which are invisible to the developer, but then it's only one single source of truth and only one place where you have to change something. But this is the way in which you break down things. But then don't go crazy, because then otherwise you don't have any more the components. Now, this is the other way around. So you have to look at your component and understand, okay, how this component is built. And then when you come out with the idea of layout and content, and when you have a component which mix the two things, I can show you maybe, give me a second. I can show you this one. Spring box, where it is, here. Now, look at this component, which is the one with the circle, the square, and the other square. No? Can you see that there is nothing about color, font, nothing? It's pure layout. Okay, when you start to see this one mixed with the color, font, it's a smell. You should break it down. There is something that probably you're mixing. Okay? You can have components with like this double behavior, but it's pretty rare. Okay? Then there is this thing called Gall's law on complex system. It's here, I'll show you it in a second. A complex system, it's like 40 years old, 70 something, like 30 or more. It's not about design system, it's not even about software. It's about complex system in general, like governments, companies, human systems, and so on. A complex system that works is invariably found to have evolved from a simple system that worked. This is, for example, is how biology works, the natural evolution. Okay? A complex system designed from scratch never works. Don't try to build a big system. Start from a small system and evolve it. Always working. And cannot be patched up. You can start, try, but will never work. You have to start over with a working simple system. The other but is, okay, we have these components, everything is a component. Wait a moment, are you sure? So, are you sure that your component library needs to cover every possible case of components? Well, this is something that you have to ask yourself. Where do you stop in the atomic design? Do you really need to go up to there? This is the question that you have to do related to your business. Each one of us probably a different answer. For some business, may make totally sense arrive here. For other business, maybe atoms and molecular, more than enough. Then leave to the developer to compose things, because each UI is completely different. So we need to do something not bootstrap, even lower. Also because this happens if you don't build your components the correct way. The cost of building more complex component can increase dramatically if you don't work via composition, I have a small object, another small object, and I combine them. So if every time you're inventing a new component, the cost is crazy. The other but is evangelization, which means if I speak with someone else, I don't know, my manager, my PM, whatever, and I show him the atomic design system, cool, I get it, cool, ooh, cool, yeah, clear. And then this is what remains stuck in their mind. This thing, oh yes, now we have components, everything will be fine. No, wait. It's not so simple. It's not just break down in atoms, because there is the human part, there is the process, there is the fact that the designer will need to have the flexibility also to change design. So you need to have a conversation between designer and developers. It's not just that schema, but this schema is what remains in the head of other people. So you have to work a lot to evangelize people in changing their mindset to just, oh, this is what we work now from now on, build some atoms, throw them away, throw them in a UI, and you have a UI. No, it doesn't work like this. So I have a couple of conclusions for you. 3, actually. One, I was preparing the slides, the slides were almost ready, but the conclusion, I would say, well, what are the conclusions in terms of what I want to say? And this was easy, because it's clear, no? So atomic design is cool, but it's just the beginning. You need to work from one single atom and start to look at the entire world, the entire ecosystem of your company, how it works, how to use this methodology and adapt it to your company, to your team, to your colleague, to your designer. It's not, oh, let's just do atomic design. Doesn't work. It's a tool. Use it, but for you. So end here, please. The second one was, I was thinking, and then I realized, wow, I wrote, look at I copied the wrong place. Sorry, I have to copy paste. It's in a blog post that I wrote like in 2015 and so on. I remember this image, I say, yes, that's what I want to say. The complexity of the atomic design is not in the atomic design itself. It's in this connection. If you have 3 atoms, if you don't find the correct way to connect them, it doesn't work. And so the organism, the complexity is here in designing the rules, how you combine the atoms. How do you, as they say, oh, we design the atoms, then we put them in a page, and whoa, it's horrible. Maybe you didn't design correctly this connector. You didn't think in terms of this connection. So this is where the complexity is where your work starts. Atomic design, cool, but don't forget about the red points. And the red points are about having an holistic view to your system, how to combine things. And can I just say something? This is maybe PM, designer, developer. How do you communicate between them? How do you pass the information? How do you create meetings in which you discuss about the component? This is not necessarily code. And this is the final suggestion. Nothing is particularly hard if you divide it in small jobs. By Henry Ford, it's in the London Museum of Design, and I think it's amazing. Like always break in small jobs. Not only it's not about atomic design. It's not about breaking down UI. It's breaking down in small jobs. Okay, that's it. Thank you.